Good morning, afternoon. Today we're going to pick up where we left off yesterday. We're going to look at, let's see, number 21. So we're under power tools at this point. So the question states, pneumatic tools get their power from, well, let me back up real quick. So we're going to go ahead and open up our textbooks to module 4. I believe it's module 4. Yes, module 4. And we're going to section 1.0.0. So let's go ahead and do that. Get your books out, get set. All right, 1.0.0. All right. Okay, so just pause the video here if some of y'all are having trouble finding it or taking a little while to get started. So, all right, so I'm going to reread the question. It says pneumatic tools get their power from, and so we're going to look here. We want to find pneumatic tools right here. Second bullet down right there on page 1 says these tools are powered by air. Electric or gasoline powered compressors produce the air pressure. Air hammers and pneumatic nailers are examples of a pneumatic tool. So I'm going to share my screen here real quick and show some examples of pneumatic tools. So as you guys can see right here, we have several different styles. Primarily what you're seeing right there are automotive. Over here on the right hand side, over here we have a trim nailer and so forth. But it's essentially it's going to be any tool that is powered by air. So, all right. So the correct answer there is going to be air pressure. So pneumatic tools get their power from air pressure. So I'll go to section 1.1.0, which is your type of power drills on page 2 right there at the bottom. So the question asks, the most common use of the power drill is to blank. Well, let's read here real quick. What do you think it is? If you said to drill holes, then you're primarily right. So it says various types of power drills are often used in the construction industry. A power drill is most commonly used to make holes by spinning the drill bits into wood, metal, plastic, and other materials. So to make holes into wood, metal, and plastic and other materials would be the correct answer there. So, all right. And I think we actually have, let me see here. Nope, that's not it. Let's see here. Power drills. There we go. There we go. We got all sorts of different power drills. We got cordless, corded. Now, as you guys are very familiar with the cordless drills, for years and years, we actually had to use the ones with the cord, especially if we were trying to get something to drill through large holes through wood. The cordless drills, the batteries just weren't powerful enough at the time years ago when I first started my career field in electrical. So we had to use the corded drills, but drills drill and drills hold, right? All right. Number 23 right there. Go to 1.2.0. 1.2.0. Flip the page over. Now, a couple of times it looks like. And if you'll look on page 6, it shows, because most all the drills we use right now are chuckless. Well, right here are perfect examples of when we use our 1/2-inch drill, which is, let's see, I thought I saw a picture of a 1/2-inch drill a minute ago. Here it is, right here, the one Amazon DeWalt hammer drill type. So that right there, see, it actually has a key chuck on it. So we actually have that drill. Requires a key to open and close to tighten up around the bits. And then, of course, on page 8, it shows the chuckless. So moving on to 1.2.0 over here on page 10, hammer drills. The question states, Excuse me, hammer drills are designed to drill into, well, they're designed to drill into concrete, block, tile, and so forth. Yeah, concrete, brick, and tile. So I was looking to see if I could see where it specifically says that, but it says a hammer drill has a light pounding action. So inside of the actual where the motor impacts the chuck, it has a cog to where it just literally will boom, boom, boom. When it rotates around, it gives that hammering effect. Because if you run a masonry bit onto a block at full rotations without it hammering, what'll happen is the actual bit will actually get too hot. The sand that's a part of that concrete will actually crystallize and cause that metal to burn, get so hot that it'll actually melt that bit. So it's super important if you're drilling through masonry, you're using a hammer drill with the appropriate type of masonry bit. And if you'll look on page 11, it gives you some examples. If you'll look at the tip of the bits, you'll notice that they actually have like almost a triangular shape, and it's got like a carbide tip on it. It's supposed to be able to withstand heat a little more so than a regular bit, but they're very distinctively different than a regular drill bit. So let's see, concrete, brick, and tile. All right, so in number 24, 2.1.1. Now, like again, that all of this should be remedial for us. If you don't remember a lot of this stuff, it's because you're either out or we went through it really fast. So we're just going to go through it. Well, we're going through it fast again. But you'll put your hands on all this at some point. Okay, here we go on page 16. How to use a circular saw. So it says right here, when cutting with a circular saw, grip the saw handles firmly with 2 hands. And I actually have, let's see, there we go. There's an image of a fella actually holding this thing just as it's, oh, that's reciprocating saw. I must have pushed the wrong one there. Here we go. Now, the gentleman over here in the Home Depot picture right here, you see how he's holding the guide and he's holding the trigger guard at the same time? That's how you're supposed to actually handle the proper use of a skill saw or circular saw. And if you'll look in figure 20 on the next page, it has an illustration of another young man that's holding it properly as well. All right. Number 25, 2.2.4. 2.2.4. So before using a reciprocating saw, let's go back to that reciprocating saw real quick. This is the reciprocating saw. You see how he's holding it? I want you to look right here where the saw actually comes in contact with that pipe right there. That is so important that you make sure that that guard is pushing up against whatever you're cutting. If not, that saw blade will get caught in the teeth of the saw will get caught in the material, and it'll jerk your arm back and forth, and that's never a good thing. So, but that's not the question. The question was asking, before using a reciprocating saw, because of the length of the blade and how it plunges in and out of the saw, before using a reciprocating saw to cut through a wall or partition, you always want to see what is on the other side of what I'm cutting. Am I going to damage what I'm cutting? Am I going to, I think the other day I had Cassidy up there and I said, hey, Cassidy, just make sure we don't hit the building with the blade. Of course, the saw kind of moved on me and I bumped the building, didn't go through it, thank goodness. But the whole point of it is you got to look at the length of your blade and will it damage something beyond the length of that blade. So it's super important that whenever you're cutting, as you can see over here in the illustration on the right hand side where it says Power Tool Reviews, look how far that blade extends beyond that piece of wood right there. So you just want to make sure that whatever you're using isn't sitting there in the way. So, all right. not in the way, but isn't damaged by it. Another point of fact on that is anytime you're drilling through a wall with a bit that's longer than the depth of the wall cavity. For example, if I wanted to drill a hole into one of the walls in the classroom right there, those walls are, excuse me, they're 8 inches thick. Okay, the blocks are about that long or thick. There's a 1-inch gap between the outside of that block and the brick. The brick is 4 inches. So between the 8, 1, 9, plus 4 is 13 inches. So if I have a drill bit that's longer than 13 inches, I need to be mindful of that to make sure I don't have someone leaned against the wall on the backside or something like that if I need to drill that hole all the way through. It's just an example, but it happens all the time. You just want to make sure that you're not hurting someone or something by not understanding what the length of what you're sawing or drilling is doing over there. So, but to answer your question, or answer the question for number 25, you want to find out what's on the other side. All right, number 26, 2.3.2. 2.3.2, safety and maintenance on page 21. There are a few basic guidelines that need to be followed to protect workers and the equipment when a portable bandsaw is used. First, always wear appropriate PPE. Glasses, gloves, hearing protection when needed. Use only a bandsaw that has a stop. Okay. I want to make sure that we understand what a stop is. Let's see here. So these are portable bandsaws. All of these are. And right there, let me see if I can click that real quick. If it'll make it larger here for me. You can see that guide or that guard right there. That's your stop. The blade is traveling in a circular motion around a couple of drums inside there. So what you want to do is you want to place your wood right there where my mouse cursor is sitting. You want to place your pipe or whatever you're cutting against that stop, because if you start it at the other side, that blade's going to pull it against you and could break the blade. It could cause you to hurt yourself, drop the saw. It could create a lot of situations. You always want to start with the material against the stop. That goes with all tools. Any drill, any saw, everything. Always put your lumber against the stop, to include the miter saw. Anytime we're cutting with that miter saw, we want to make sure that the wood's tight up against the guide in the back. And then because the blade's turning that direction, it's actually turning against so that it pulls that. I had a student years ago, same scenario, didn't really understand, told him not to, I specifically told him, don't do it. And he was out. I told him just shadow the other guys, blah, blah, blah. Well, went out in the shop. Now, granted, these were adults, so I don't have to watch them all the time. So, but I told him just shadow the guys. They were building something outside. And one of the guys didn't realize that I didn't tell him. So he told him just go in there and cut this board. Well, he threw the board down, did not put it up against the stop. He did have a hold of it. When that blade hit that saw, or that saw blade hit that wood, it slammed the wood so hard against the fence in the back, busted all his knuckles right here. Every one of them were bleeding. So my point being is, always make sure that you're putting your lumber against that stop. The stops are there to hold it, to assist you in holding it. All right. Yeah. All right. So number 26 said right here, use only a bandsaw that has a stop. Stop is that bracket, is that guide, is that thing that holds against the lumber. All right, so let's move on to number 27 right here. Now it says the blade of an abrasive cutoff saw. So let's talk about cutoff saw real quick. That's going to be right here under our angle grinder. So these type of saws here, these are right angle grinders. But if you look at the discs here, some are thin, some are thick. They all have different purposes. The thicker ones are designed for grinding and shaving. The thin ones are designed to cut through something. So the blade of an abrasive cutoff saw spins at such a high speed that the resulting friction is hot enough to burn through the metal. So what we use on these blades that you see right here, those blades right here, discs, they are thin and they're made of carbon. So what happens is, as you're cutting material and so forth with it, it's actually burning its way through it. Now, granted, the carbon blades are being eat up a little bit by it. You don't ever want one of them things to get in a bind either, because they get at such high temperatures that when you bind them and they're going that fast, they explode. And when they explode, it's not good. Let's see. So I'm going to repeat that. The resulting friction is hot enough to burn through the metal. That is the answer for number 27. And at any point, if you can't get it fast enough or can't get it written fast enough, just ask Miss Smith. If you would, Miss Smith, just stop it, rewind it for a second, this video for a second, if I go through something a little too fast, because I know I am talking fast. This video probably won't be 30 minutes. It'll probably be closer to like 20. So anyway, we'll move on. So let's talk about powder actuated fastening systems. Now, powder actuated fastening, powder actuated fastening systems are essentially they're 22 pistols. So anyone that's fired a gun before, that sounds just like a 22 pistol being fired. Okay. So because not essentially, so what we're using is a blank. Now these cartridges are colored. They're specifically for different length of nails. So what we're trying to do is we're trying to drive a nail through something into concrete. So we use this powder actuated gun to actually fasten it into concrete. So see if we have an image here. They're putting metal siding to that wood, it looks like. Over here on the right, they're fastening brick ties to a solid concrete wall. There's multiple things. Over here on the left, they're ram setting or they're fastening, looks like plywood to the side of concrete. So they're designed to fasten to concrete. And I mean, at some point we will have them out there and I will demonstrate it. But beyond that, you personally will not be using this. You're not necessarily allowed to use this because it is a gun. So, all right. So, if you'll turn your book to 4.1.0, 4.1.0, 4.1. There we go. All right. So we are on page 31. Shows pneumatic and powder actuated fastening systems. So the question is, powder actuating fastening systems are used to, and of course, anchor static loads. Static loads mean things that hang. They're just something that hangs from something. So anchor static loads to a steel beam. Okay, so that's just one of its applications anyway. All right, so number 29, 4.3.0. Now, if you'll look, there's pictures of the on page 32. If you can look back there real quick, you can see those are the bullets and those are the nails. And that's just one of the tools. And then it shows it actually fastening a bottom plate down to the concrete over here on figure 41 on page 33. Number 29, 4.3.0. Okay, hydraulic jacks. Let's see here. Hydraulic jacks. Hydraulic jacks come in all different things. We use hydraulics very often. You can see that there's multiple uses for these, but it's primarily as a jack. So you just need to know when you're dealing with hydraulic fluid, it's designed to be able to push a cylinder through extreme pressure. So obviously, as you tighten the bleeder valve up, you jack it up, pump it up, whatever you're doing, and then once you're done, you release that pressure valve, and then of course the jack or whatever you're doing will retract back into the cylinder. So the question says hydraulic jacks are used when the application calls for, it says hydraulic tools are used when an application calls for extreme force to be applied in a controlled manner. Makes sense. All right, so now let's flip on over to construction drawings. Now we're going over to module 5. We're going to start out in 1.1.4. 1.1.4. So we're going to start here. Now these, in this one here, we're going to jump around a little bit in the book. So don't be surprised if I say, if I go from 1.2 to 1.1. So, because that's going to happen. All right, so let's talk about mechanical plans. Anytime you think of mechanical, of course, we thought about plumbing, air conditioning, stuff like that, right? Those are your mechanicals. So let's look at our mechanical plans. They're engineered plans for motors, pumps, piping systems, and piping equipment. And the reason HVAC is included in all that pumps and stuff like that is because a lot of time, for years, and even on some of the current systems, we use boilers. And the boilers are essentially, I'm not going to go into the engineer mechanical part of it, but it has pumps and motors, which builds up pressure, which pushes, creates heat and steam and stuff like that for the boilers. But what that means, though, is for question number 30 is which type of plan shows the layout for the HVAC system? That's the mechanical plans, right? All right. Number 31, 1.2.1. Flip through all these drawings here. Okay, so we're in title block. We're just going to go over a couple things because title blocks, we've been drawing a few of them in class, and I've been having you draw the long rectangle, but put it into 3 portions. Put the, I think I had you put what period it is, what's your name, and then put down at the bottom the date. The date is part of the revision because that's when we know when it was most currently drawn, or if any modifications were done. We always look at the revision date to determine when is what on this drawing here, where does it fall as far as how many modifications has been made to it, either by the customer, engineer, or contractor. So in that one there, it's going to be the title block generally contains, of the choices that you will have, will be revision block. There's one of them gets in there. Of course, in addition to revision block, it's going to be the customer's name, the builder's name, or the architect's name, and so forth like that. All right. We're going to flip back a couple pages to 1.1.6. Heading back from where we came from. Looks like I went too far. If someone finds it, obviously, please let everybody else know what page they're on, and then I will catch up with you guys, it looks like. It seems to be all up in some different pages here. 1.1.6. Let's see here. Okay. Beyond that. Nope. 1.1.4. 1.1.7. Wish you guys could help me out. Where is that page? That somehow went from 1.1.4 here. Let me see. On page 14, I'm not seeing 1.1.6. There we are. We're on page 20. Sorry about that, guys. So the electrical plans are engineer drawings for electrical supply and distribution. These plans may appear on the floor plan itself or simple construction projects. Electrical plans include locations of electrical meter, distribution panel, switchgear, convenience outlets, and special outlets. For more complex projects, the information may be on a separate plan added to the set of these plans. This separate plan leaves out construction details and shows just the electrical layout. So the question is asking, which I did not read, but it is on there. Electrical plans can include lights, which is odd. Did I read that? These plans may appear on the floor plan. Simple. Include electrical meter, distribution, switchgear, convenience outlets, special outlets. Let's see here. Maybe there was another. For more complex plans, include locations of switchgear, transformers, main breakers, and motor controls. Electrical plans usually start with a set of general notes. These notes cover items ranging from main transformer to the coordination of underground penetrations into the building. The electrical plans can include lighting plans. It says it can. Oh, there it is. Electrical plans can include, which show the location of the lights and receptacles. And of course, examples for all of that. Probably right here if I had to guess. If you'll turn on page 25 there, that'd be a portion of an electrical plan there. Page 26 is your panel schedule. Panel schedules, just briefly talk on that for a second. Panel schedules essentially says this breaker controls this, and that's all that is really. So, all right, we're going to move on to number 33. We're going to bounce forward a little bit to 1.5.3. 1.5.3. Once again, let's see if we can find. There we go. We're talking about engineer. Now, you have imperial and you have metric. Imperial is essentially what we use. It's the American standard. Metric system is the European standard, which deals with the metric scale. The architect scale, which you guys should be somewhat familiar with by now, at least have seen me using it if you haven't done it yourself. So on that note, there's an engineer scale that is triangular, just like that one was, but everything is in centimeters, millimeters, et cetera, right? So one thing we want to know is, or understand, is that anytime you're dealing with our engineer scale, it's always set up in multiples of 10. Everything's a multiple of 10. It says engineer scale is mainly used for land measurements on site plans. Makes sense, right? If you have, say, 50 acres, you can't do it with a 16th equals a foot. You want to go to the metric system, so it can be 1 centimeter equals 200 feet, because you only have a piece of paper that's 22 inches. I think it's like 22 inches wide and almost 30 inches long. You don't have the space to put all that information on that paper if you use imperial standard. So we use metric system, and which means the scale must accommodate very large measurements. Each engineer scale is set up as multiples of 10, and the measurements are taken in decimals. This is different from the architect scale, that a unit is represented by a portion of an inch. The most common engineer scale are 10, 20, 30, 40, 50, and 60. All right, so 10 is the correct answer to that. Number 34, we're going to jump back a couple pages, 1.4.1, to dimensions. So dimensions is nothing more than what's the distance from this location to this location. You guys see me do it all the time. When I draw a line and I put how far apart it is, and I'll put a little arrow on each end of that, those are dimension lines. So the dimension is the actual measurement itself. Okay, dimension lines are the lines themselves. The dimension is the number I put in that space, which is essentially 10 feet, 20 foot, whatever the distance is from here to here. So anyway, when using the metric system, when the metric system is used, dimensions are written in meters, centimeters, and millimeters. Okay, so when we write them in the metric system, meters, centimeters, millimeters. All right. Not sure where we're at on time right now, but we're just going to push forward. So we're going to jump back to 1.2.4. Yeah, let's go ahead and do that. I was going to talk on it, but we'll go ahead and do that. 1.2.4. Revision block. A revision block is located in the drawing area, usually in the lower right corner inside the title block or near it. Different companies put the revision blocks in different places. This block is used to record any changes or revisions to the drawing. It typically contains the revision number, a brief description of the date, and the initials of the person who made the revision. Okay, so number 35, the latest revision date on a set of construction drawings can be found inside the title block, which we already talked about. Easy peasy, right? All right, last but not least, let's go over this. Okay, let's see if I can get that up there, y'all. I think it's probably backwards if I had to guess. Y'all probably seeing all that backwards. But anyway, look on your plot drawings. One, as you notice, I put 1, 3, 6, 7, 8. I didn't need replica, but that I just needed these. That's all I wanted. So number 1 is the double top plate. Number 2 is the header. Number 3 is a king stud, or I'm sorry, double head top plate. Number 3 is header. Number 6 is a king stud. Number 7 is trimmer stud, and number 8 is a rough seal plate. Once again, if I spoke way too fast, you can always just back it up a little bit and then just review it again. So, all right. So, Miss Taylor, go ahead and please let them take these few minutes that's remaining in class. Study with your mouths closed. Focus on your paper, not your partner's. You will know this by looking. You study your material and not your partner's, because I promise you guys, if you just take the time to listen and learn, or read through the notes that you've written, maybe you didn't get all the notes or something. If you need to get help from someone else, that's fine. I don't mind that, but we're not talking across the room to try and get information. Miss Taylor, I'm sorry, Miss Smith, if you could just be awesome like you are, just facilitate this, and I think we're good. Good luck. Hopefully I can get Blooket set up and ready for tomorrow and get you guys some test prep stuff. And yeah, we'll be ready for that test on Thursday and Friday. So anyway, see y'all tomorrow.